Okay, so I think what you've got going on here, I'm trying to get the idea here. I think what you're saying is you're trying to use this formula here, the probability of A given B is equal to the probability of A and B divided by the probability of B, because it looks like that's what you're setting up here. Now, the big thing to understand is you don't need all three. What they're saying here is you can calculate, one way to look at this is you can calculate this, or if that's too hard, you can do these two. So you kind of just do whichever is easier to do, but you don't do all three. So it looks like you're saying, okay, I'm going to do this one, and because this one looks hard to do. Okay. Now the next thing that's really helpful is to define what A and B mean. So I'm going to guess that you're saying A is she gets all the red, and B is she gets the pink. Let me know if that's wrong. That's how I'm going to attack this problem. So what I'm seeing here, when you quickly do the math, 1 combinations of 1 is 1, 4 combinations of 4 is 1, so 1 times 1 makes 1. The denominator is 13 combinations of 5. The numerator, again, 1 combinations of 1 is 1. 12 combinations of 4 is 495, and again, the denominator is 13 combinations of 5, just leaving those alone. So that is how I see these two being worked out. And so you can see we don't need, for this formula, we don't need the probability A. This is just all, we don't need it. So now, just fill this into the formula. The probability of A given B is equal to the probability of A and B, which is what you have here, and you set it up perfectly. You said first we're going to say out of the 1 pink we need to pick 1 of them, then out of the 4 reds we need to pick 4 of them. That takes care of all 5 of our marbles. And the total number of outcomes would be 13 out of the 13 marbles we need to pick 5. Then for the numerator, for the probability of B, that is just the probability of getting the pink. So out of the 1 pink, we're going to pick the 1. Then there are 12 remaining marbles. Out of those, we need to pick 4 more to fill in our hand, because in just the probability of B, there's no restriction of getting all reds. So that looks perfect. So now when we set this up using the formula, I end up with 1 over 13 combinations of 5 divided by 495 divided by 13 combinations of 5. Now this is a complex fraction, so when we do this we flip and multiply. So this is 1 over 13 combinations of 5 times 13 combinations of 5 divided by 495. That divides with that. Actually, you know what? Let me just, that divides with that, whatever, that and that. So now I'm just left with, when this simplifies down, 1 over 495. And by the way, that happens to be the answer. So your question was, how are you doing on this? Are you setting it up right? Yeah, you're doing great. It looks like you just had some extra information. But the one thing I would like to point out is I personally think it's much easier just to attack this with the probability of A given B idea. So saying, given that the pink has already happened, given that you know you're going to pull a pink out. It's done. It's already happened. You reached in, you pulled 1 marble out, it was pink. So now you're saying to yourself, okay, now what's the probability? So probability of A given B. So given, you've already pulled the pink out, what's the probability that you're going to get all the reds? Well, so we have to guarantee 4 combinations of 4, guarantee you have all the reds, divided by, and then that would fill in our hand, because that would give us all 5 marbles. So because we have to pick out of the 4 reds, we have to pick 4. We've already pulled the pink out, so that gives us a total of 5. So then for the denominator, now we're just saying, okay, the denominator is what? Well, since we've already pulled the pink out, there are 12 marbles left in the bag, and we're going to pick 4. Do note, that's the same as what we already calculated. That gives us 1 out of 495, and voila, same answer. So personally, I like this method much better for this particular problem. It's not always easier, but I thought it was for this one, because the given is very easy for me to conceptualize. You can easily imagine picking 1 marble out of a bag and already having it in your hand, and now somebody looking at you and saying, what's the probability that you're going to pull out 4 more now? What's the probability they're all going to be red? And so there you go. Anyway, I hope it helps.